Hello, today we are going to learn about similar figures. Now this is okay. Unlike the congruence, yeah, similar here in maths means that they must be the same in terms of shape, but they might have different size. Example like this. All right, they are exactly the same shape, but not the same size. So they are not congruent, but they are similar. Right? Understand? Yeah. All right. Sorry. Oops. Okay. If two similar figures also have exactly the same size, then they are congruent, right? So similar is only same in size. Congruence is same in size and sorry, similar is only the same in shape. Yeah, similar, yeah. But in congruence, the same in shape and size, both. Now, remember back then when we want to determine whether two figures are congruent, we compare the angles, make sure they both have the same angles, and then we compare the size also, right? The length of the figure, the size, make sure they all have the same length, yeah, the size. But in similarity, we only compare the angles because we know the size is not necessarily the same, right? It's not the same. So all corresponding angles are equal. All the ratios of corresponding sides are equal. Now, it is very important to notice that they might not have the same length of sides, but the ratio must be the same. I'll show you why. Okay, just take a look at this work example 5. ABC is similar. Is ABC similar to QR? Explain the answer now. Sorry, I have a lot of things, stuff flying around here, but some of them can help us to understand more. So, are they similar? First thing to do, compare the angles. This one is 70, 49. That means this one is 180 minus 70 minus 49. Right? Which is 61. Now this triangle here got 61 and 70. The last angle is 180 minus these two, which is 49. Now you notice that they both have the same angles. Check. Almost similar, but remember the second rule is to make sure that all the sides, all the corresponding sides, even though they are not exactly equal, but the ratio must be equal. So there's no length given here. So for this A, we can consider it it's done already. So it's similar, yeah. Now for number B, is DF similar to STU? Explain your answer now. Okay, because there are no angle here given, we just compare the length of the sides. We need to make sure that they are not the same, but the ratios are the same. So we have 4, 6, 8 here, and we have 12, 9 here. Now, what can we see here? What we can see here is when you times 6 with 1.5, you will get 9. Yeah, 6 times 1.5, you get 9. 8 times 1.5, you'll get 12. Right? So that means we have to check whether 4 times 1.5 is 7. 4 times 1.5 is not 7, it's 6. So this should be 6. Okay? But this is 7, right? So that means the ratio are not equal. You understand what I mean? The ratios are not equal. 8 and 6 here are good already. They both times 1.5 to become this one, but 4 does not time 1.5 to become this one, so it's different. This 4 is kind of different from this 2, so that means this is not a similar shape. So again, let me make a conclusion once again. So you can, I think you can either let me see. You can either compare the angles or the ratios of the sides. I think you just need to do one of them. Depends on what is given from the question. This one, angles are given, so you make sure the angles are the same. This one, length is given. That means you have to make sure that the ratio of all the length are equal. So these two triangles could be similar if just this is 6, not 7. Now how do we know? How do we know that we need to times 1.5 to turn this triangle to this? This one where it's kind of hard. You have to use your intuition, use your feelings to get to see it. All right. This one. Actually, the solution is given already. This one is for finding the angles, so similar. This one is not similar, right? Because now here again, they have kind of different way than mine. I times 1.5 to check the other side, the other triangle, the corresponding side. We call that corresponding side. It means that for this one 8 match with this 12, right? How do we know? How do we know not to compare, for example, how do we know not to compare 8 with 9, for example, and 6 with 12? How do we know I need to compare 8 with 12? Just notice that 8 and 12 are both the longest side of the triangle. 6, 4, 6, 8, 7, 9, 12. So of course I need to compare the longest one with the longest one. 4 is the shortest side, so I need to compare 4 with 7, which is the shortest side also. And 6 is kind of middle, the middle one. So I need to compare 6 with 9. 9 is also the middle one. Okay. Now the way you compare, this is very, very neat. Okay. So you just divide the corresponding sides. This is the longest with the longest, the middle with the middle, shortest with the shortest, just like that. Make sure they are all the same result. Now turn out that this is not the same result, right? This is 4, right? That's what I mean. So instead of using my way, I will recommend just use this way. So again, divide longest side with another longest side, divide the medium side with another medium side, divide the shortest side with another shortest side. Make sure that the ratio, this result is called the ratio. Make sure all the ratios are the same. If they are the same, they are similar. They are not the same, one of them or two of them are not the same, then it is not a similar figure. Okay, there are more examples which I will cover in the next video.